blobfish is often called the ugliest animal on Earth. Most people recognize the image instantly: a sagging face, a body that looks like it's melting. But that is not what this animal actually looks like. That photograph was taken after the fish had already left the environment it was built for. By the time we see it, something has gone wrong. Far below the surface, nearly 1,000 meters down, the same animal exists in a completely different form. There is no sunlight there. Pressure rises to more than 100 times what we experience at sea level, and in that world, the blobfish does not collapse. It holds its shape. Its body is soft, almost weightless, designed to drift just above the seafloor where food is scarce and movement must be efficient. It does not fight the pressure, it depends on it. Remove that pressure, and the structure begins to fail. The familiar ugly face is not its natural form. It is the result of being pulled into a world it was never meant to survive. Very few people have ever seen this animal alive where it belongs. Most of what we think we know comes from a single moment after everything had already changed. So what does the blobfish actually look like in its own environment? And how many other deep-sea creatures are we completely misunderstanding in the same way? Tonight, we're going to follow that familiar image back down into the deep ocean and see how the blobfish truly exists in the environment it was built for. Before we go any deeper, if you enjoy calm, curiosity-driven science like this, consider leaving a like and subscribing. It helps this small corner of the internet continue to grow. Now let's start our descent. Long before its image drifted into public awareness, the blobfish existed only as a quiet anomaly, pulled from depths that resisted observation. Its first appearances did not come through deliberate study, but through the heavy, methodical sweep of deep-sea trawling nets, lowered into waters where light had long since vanished. These expeditions were not searching for anything so specific. They moved slowly across the seafloor, gathering whatever life happened to exist in those distant layers, lifting fragments of an unseen world toward the surface. Among the tangled catch, strange forms often emerged, softened by the journey upward, altered in ways that were not immediately understood. Early researchers sorting through these collections encountered bodies that seemed incomplete, as if something essential had been lost along the way. The blobfish was one of these, a presence without clear structure, its features difficult to interpret, its form offering few clues about how it had once lived. For much of scientific history, the deep ocean remained beyond reach. Traditional methods allowed only brief and indirect contact, and most encounters with deep-sea organisms occurred after they had already been removed from their natural conditions. This created a persistent uncertainty. Creatures like the blobfish were not observed in motion, not seen interacting with their surroundings, but instead examined in stillness, their forms already changed by a scent. It was not until the expansion of systematic fishing surveys around the waters of Australia and New Zealand that the blobfish began to appear with greater consistency. These surveys, designed to map marine populations and understand fisheries, extended into deeper regions along the continental slope. Trawling equipment became more capable, able to reach depths that had once been inaccessible, bringing back specimens that hinted at a complex and largely unknown ecosystem. Within these collections, the blobfish appeared again and again, though never in large numbers. Its presence was subtle, easily overlooked among more structured species. Each specimen carried the same quiet ambiguity. Without the context of its environment, its anatomy seemed almost formless, lacking the rigid framework that biologists were accustomed to studying. Classification became a slow process, requiring comparison with related species and careful examination of tissue and skeletal remnants. Marine biologists at the time relied heavily on preserved specimens, often fixed in solutions that further altered their appearance. The blobfish, already delicate, became even more abstract under these conditions. Its true proportions were difficult to determine, and its relationship to other fish within the cycroludid family was not immediately clear. It shared certain traits, reduced bone density, minimal musculature, yet these features appeared exaggerated, as though the organism itself had been partially dissolved. This led to early misunderstandings about its nature. Some interpretations suggested a malformed individual, others considered it an unusual variation of more familiar deep-sea species. Without direct observation in its natural habitat, there was no clear reference point, only fragments of evidence shaped by the limitations of available technology. As surveys continued, patterns slowly emerged. The blobfish was not an isolated curiosity, but part of a broader group of deep-sea organisms adapted to similar conditions. Its repeated appearance in trawl samples suggested a stable, if sparsely distributed, population. Yet even with this growing recognition, its true form remained elusive, hidden beneath layers of distortion introduced during collection. In this way, the earliest encounters with the blobfish were defined by absence as much as discovery. Scientists held the physical evidence in their hands, yet the living creature itself remained distant, its identity suspended somewhere between what it was and what it had become on its journey to the surface. At a depth where distance is measured not in meters, but in layers of silence, the ocean begins to settle into a different kind of existence. Movement becomes subtle, almost suspended, and the surface world feels impossibly far away. Here, along the long descent of the continental slope, the seafloor stretches outward in quiet gradients, a vast expanse shaped more by time than by motion. The environment surrounding the blobfish is defined by stability rather than change. Temperatures remain low and consistent, often hovering just above freezing, held in place by the immense volume of water above. There are no seasons in this depth, no warming currents from the sunlit layers above, only a steady cold that permeates everything it touches. It is a temperature that slows processes, softens urgency, and favors forms of life that can exist without haste. Light does not reach this world. Even the faintest traces from above are absorbed long before they approach the seafloor. The darkness here is not simply an absence, but a constant presence, unbroken and complete. Without sunlight, there are no shadows, no shifting patterns across the terrain. The landscape exists in a kind of visual stillness, where form is sensed rather than seen, and life unfolds without the rhythms that light once imposed. Along the continental slope, the terrain gently inclines, marking the boundary between the shallower continental shelf and the deeper ocean basin. This region holds a quiet complexity. Fine sediments settle across its surface, forming soft layers that shift slowly over time. Occasional outcrops of rock interrupt the smoothness, offering structure in an otherwise uniform environment. It is within this setting that the blobfish moves, hovering just above the seafloor, carried more by balance than by effort. Water in these depths is never entirely still. Slow currents drift along the slope, guided by the contours of the ocean floor and the distant influence of global circulation patterns. These movements are subtle, often imperceptible in the moment, yet they shape the distribution of nutrients and life. Particles descend from above, fragments of organic matter that have traveled from the surface over long periods, settling gradually into this deeper layer. This steady descent forms a quiet connection between worlds, linking distant ecosystems through a continuous, almost invisible exchange. Despite its vastness, this region remains one of the least explored on Earth. The depth alone presents a barrier, requiring specialized equipment capable of withstanding immense pressure and extended periods in isolation. Human presence here is rare and fleeting, limited to brief observations through remote vehicles or instruments lowered from the surface. Each visit offers only a narrow glimpse, a small window into an environment that extends far beyond immediate reach. The difficulty of access has shaped our understanding. Much of what is known comes from indirect observation, from data collected in fragments and assembled over time. The contours of the seafloor are mapped in broad strokes, and the life within it is often inferred rather than directly witnessed. Creatures like the blobfish exist within this uncertainty, their behaviors and interactions largely hidden within a landscape that resists detailed study. Yet within this quiet, there is continuity. The conditions remain steady across vast distances, allowing life to persist in forms that do not rely on rapid change or abundant energy. The deep ocean does not demand speed or strength, but rather a careful balance with its surroundings. In this still and unlit world, existence unfolds slowly, shaped by forces that operate beyond immediate perception and sustained by a delicate harmony between organism and environment. Weight accumulates in the ocean not as a sudden force, but as a gradual and unbroken layering, each meter of water resting upon the next. With every descent, the surrounding mass becomes denser in its effect, pressing inward from all directions at once. There is no single direction to resist, no surface to brace against, only a steady, encompassing compression that increases without pause. Near the surface, this pressure is barely noticed, balanced easily by the structures of most marine life. Yet as depth increases, the force multiplies in a precise and predictable way. Roughly every 10 meters adds another atmosphere of pressure, a unit equal to the weight of the air pressing down at sea level. By the time the descent approaches 1,000 meters, that accumulation has reached more than 100 atmospheres, a magnitude that reshapes how matter itself must be arranged to remain stable. At such depths, the familiar forms of life from shallower waters would begin to fail. Gas-filled spaces, so useful near the surface for buoyancy and respiration, become points of vulnerability. Under increasing pressure, these spaces compress, their volumes shrinking rapidly, altering the balance within the body. Tissues designed to operate under lighter conditions are forced into configurations they were never meant to sustain. Movement becomes difficult, internal systems lose their equilibrium, and survival becomes unlikely. The challenge is not only the intensity of the force, but its constancy. Pressure at these depths does not fluctuate with time of day or weather. It remains steady, unchanging, an ever-present condition that defines the limits of existence. Organisms that live here cannot rely on temporary resistance or structural rigidity alone. They must be shaped in ways that allow the pressure to pass through them rather than oppose it. This is where deep-sea life begins to diverge from more familiar patterns. Instead of rigid frameworks and enclosed cavities, many organisms adopt forms that are more flexible, more permeable to the forces around them. Their bodies contain fewer compressible spaces, reducing the risk of collapse. Fluids replace gases, and tissues are arranged in ways that distribute pressure evenly, preventing localized strain. In the case of the blobfish, this adaptation takes on a particularly refined form. Its body composition allows it to exist in near equilibrium with the surrounding water, minimizing the difference between internal and external pressure. Without the need for a gas-filled swim bladder, it avoids one of the most common vulnerabilities found in other fish. Its structure does not resist the environment, but aligns with it, maintaining integrity through balance rather than strength. Other deep-sea organisms follow similar principles, though expressed in different ways. Some develop reinforced cellular structures that remain stable under compression, while others rely on biochemical adjustments that keep proteins and membranes functioning despite the intense conditions. Enzymes within these organisms are adapted to operate under high pressure, maintaining metabolic processes that would otherwise be disrupted. Over long periods, these adaptations become embedded in the lineage of deep-sea species. Evolution favors those configurations that can persist without constant strain, leading to forms that may appear unusual when removed from their environment, but are precisely suited to the conditions in which they evolved. The pressure that would crush most life becomes, for these organisms, a constant companion, shaping their existence without overwhelming it. Within this immense and unyielding force, a different kind of stability emerges. Life does not resist the weight above it, but settles into it, finding forms that can endure without conflict. In this way, the deep ocean becomes not a place of destruction, but a realm where survival is defined by quiet adaptation to a pressure that never lifts. There is a quiet softness to the blobfish, not in the sense of fragility, but in the way its form yields rather than resists. Its body does not present the firm outlines often associated with fish from shallower waters. Instead, it is composed of a gelatinous matrix, a substance that holds together without rigidity, shaped by the surrounding conditions more than by internal tension. This texture gives it a presence that seems almost unfinished when viewed outside its native environment, yet within its proper setting, it achieves a precise and stable form. The material that makes up much of its body has a density only slightly less than the water around it. This subtle difference allows it to exist in a state of near suspension, neither sinking heavily into the sediment nor rising upward. It occupies a narrow balance point where gravity and buoyancy meet without conflict. In this equilibrium, movement requires very little effort, and the body can remain poised just above the ocean floor, carried gently by the slow passage of surrounding water. Unlike many other fish, the blobfish does not rely on a swim bladder to regulate its position in the water column. In species closer to the surface, this gas-filled organ acts as a buoyancy control system, expanding or contracting to adjust depth. At greater depths, however, such structures become difficult to maintain. The compressive force of the surrounding water alters the volume of gas, making stability harder to achieve. By existing without this feature, the blobfish avoids the need to constantly adjust internal pressure, allowing its body to remain consistent despite the conditions around it. This absence shapes the rest of its anatomy. Without the support of a swim bladder, the blobfish depends on the natural properties of its tissues to maintain position. Its gelatinous composition distributes mass in a way that aligns closely with the density of seawater at depth. This reduces the need for active swimming, as the body is already balanced within its environment. Small adjustments, subtle shifts of fin and posture, are enough to maintain orientation without significant expenditure of energy. Musculature in the blobfish is present, but not heavily developed. Strong, fast contractions are unnecessary in a setting where rapid movement offers little advantage. Instead, the body favors efficiency over speed. Energy is conserved through stillness, and motion is used sparingly, only when it serves a clear purpose. This approach reflects a broader pattern among deep-sea organisms, where resources are limited and every action carries a cost. The internal structure follows the same principle. Bones are lighter and less dense than those of more active fish, reducing overall weight while maintaining enough support to preserve form. Organs are arranged to function within the constant pressure, their processes steady and unhurried. There is no need for sudden bursts of activity or rapid changes in state. Everything operates within a narrow range, tuned to the consistency of the surrounding world. In this way, the blobfish becomes an example of alignment rather than resistance. Its body does not attempt to overcome the conditions of its environment, but instead reflects them. Each aspect of its structure contributes to a balance that allows it to exist with minimal effort, conserving energy over long periods. What might appear unusual when removed from that environment is, in its proper context, a form of quiet precision. The gelatinous body, the absence of gas-filled structures, and the careful distribution of mass all serve a single purpose: to remain suspended in a place where stability is achieved not through force, but through harmony with the surrounding pressure. Motion in this depth becomes something measured in pauses rather than distance. The blobfish exists within that quiet rhythm where activity is not defined by pursuit but by presence. It does not move with urgency or direction in the way many animals do. Instead, it remains close to the seafloor, its position held with minimal effort, its body responding gently to the slow passage of water around it. There is no need for active hunting here. The environment does not reward speed or sudden bursts of movement. Energy is limited, and every motion must be weighed against what it returns. The blobfish follows a different approach, one shaped by restraint. It allows the surrounding currents to carry potential nourishment within reach, relying on timing rather than chase. Suspended just above the sediment, it becomes part of the landscape itself, neither fully settled nor distinctly separate. Its fins make only slight adjustments, subtle enough to maintain position without drawing attention. In this stillness, it is not inactive, but carefully balanced, existing within a narrow margin where effort is reduced to the smallest possible amount. Food arrives gradually, carried by the same gentle movements that define the environment. Small crustaceans, fragments of organic matter, and drifting organisms pass through this space without pattern or predictability. The blobfish does not seek them out over distance. Instead, it waits within the flow, allowing these resources to come within reach. When they do, its response is simple and efficient, requiring little movement beyond what is necessary to consume. This method reflects a broader principle of life at depth where patience replaces urgency. The constant conditions of the environment encourage a slower pace, one that favors endurance over activity. The blobfish embodies this principle through its behavior, conserving energy over extended periods, avoiding unnecessary exertion. Time, in this setting, unfolds differently. Without rapid changes or external cues, moments blend into one another, and life proceeds at a steady, unbroken pace. The blobfish adapts to this continuity, its actions spaced apart, its needs met without haste. There is no advantage in constant motion, no benefit in excess activity. Survival is achieved through careful balance, where stillness becomes a form of efficiency. The surrounding currents, though subtle, play an essential role in this way of life. They act as quiet conveyors, moving nutrients across the seafloor in slow, consistent patterns. The blobfish aligns itself within these movements, positioning its body where the flow is most likely to bring sustenance. This alignment reduces the need for exploration, allowing it to remain within a stable area while still accessing the resources it requires. Over time, this approach shapes not only behavior, but also expectation. The blobfish does not depend on frequent encounters or abundant supply. It is adapted to scarcity, capable of enduring long intervals between feeding opportunities. Its metabolism reflects this, operating at a rate that supports prolonged periods of minimal intake. In this way, stillness becomes more than a lack of motion. It is a strategy, refined over generations, that allows life to persist in an environment where energy is a limited resource. The blobfish, through its quiet presence near the seafloor, demonstrates how survival can be achieved not through action, but through the careful management of effort. Within the slow drift of this world, existence is sustained by patience. The currents continue their steady movement, carrying with them the fragments of life from elsewhere, and the blobfish remains where it is, poised within that flow, its stillness forming a subtle connection between its body and the quiet rhythms of the deep ocean. Food, in this depth, arrives without announcement, carried in fragments and passing forms that drift through a quiet and patient world. The blobfish does not search across distance to find it. Instead, nourishment appears gradually within reach, moving with the same slow currents that shape everything else in this environment. Each encounter is brief, unplanned, and shaped by proximity rather than pursuit. Among the most common sources of sustenance are small crustaceans, delicate creatures that move close to the seafloor or are carried along by shifting water. These organisms, often no larger than a few centimeters, form a steady part of the available food supply. Their movements are subtle, their paths unpredictable, yet over time they pass through the same spaces where the blobfish maintains its position. When one drifts near enough, the response is simple: a quiet extension of the mouth, a movement that requires little energy, yet provides essential nutrients. Sea urchins also become part of this diet, though not through active hunting. Juvenile individuals or weakened forms, loosened from their hold on the substrate, may roll slowly along the bottom, guided by faint currents. In these moments, the blobfish encounters them not as targets, but as opportunities, accepting what arrives rather than seeking it out. The interaction remains brief, integrated into the stillness that defines its behavior. Mollusks contribute another layer to this quiet exchange. Small bivalves and soft-bodied species inhabit the sediment, some partially buried, others resting on the surface. Disturbances in the seafloor, whether caused by shifting sediments or the passage of other organisms, can expose them. Once dislodged, they may be carried short distances, entering the narrow space where the blobfish exists. Their presence is not constant, yet over extended periods, they form a reliable part of the overall intake. Alongside these more defined organisms, there is also a steady fall of organic debris, material that originates far above and settles gradually into the deep. This includes fragments of plant matter, microscopic organisms, and the remains of life that once moved in brighter waters. As these particles descend, they accumulate on the seafloor or remain suspended just above it, forming a diffuse but continuous source of nutrition. The blobfish incorporates this material into its diet as it becomes available, taking in what drifts close enough to reach. This method of feeding reflects an opportunistic strategy, one shaped by scarcity and unpredictability. There is no single dominant food source, no consistent pattern that guarantees regular intake. Instead, the blobfish relies on a combination of encounters, each one contributing to its overall survival. The variety of available food, though limited, allows for flexibility, ensuring that the absence of one type does not prevent sustenance entirely. Energy conservation remains central to this approach. By minimizing movement and avoiding unnecessary effort, the blobfish reduces the amount of food it needs to sustain itself. Its metabolism is aligned with this pattern, allowing it to function with relatively low intake over extended periods. Each feeding event, though small, becomes sufficient within this broader balance. The surrounding environment supports this quiet exchange. Currents continue to move gently across the seafloor, carrying with them the scattered elements of life from elsewhere. The blobfish remains positioned within this flow, its presence steady, its actions minimal yet effective. Over time, these small interactions accumulate, sustaining a life that depends not on abundance, but on the consistent arrival of what is available. Within this system, feeding is not an active process of seeking and capturing, but a passive integration with the movement of the environment. The blobfish becomes part of that movement, receiving nourishment as it passes, each moment of intake blending seamlessly into the stillness that defines its existence. The edge of a continent does not end abruptly beneath the sea. It descends in a long and gradual transition, a sloping boundary where shallow foundations give way to deeper expanses. This region, known as the continental slope, forms a quiet margin between two worlds, neither fully part of the coastal shelf nor entirely within the open abyss. It is here that the blobfish is most often found, occupying a narrow band along this descending landscape where conditions remain stable across great distances. The geography of the continental slope is shaped by time and gravity. Sediments from the upper layers slowly accumulate, drifting downward and settling along the incline. Over long periods, these materials form soft terraces, interrupted occasionally by ridges and channels carved by underwater flows. The terrain is neither flat nor sharply defined, but gently varied, creating a mosaic of microhabitats that support different forms of life. Along the coasts of Australia and New Zealand, this slope extends for vast stretches, tracing the outlines of the continents beneath the water. These regions are influenced by deep ocean currents that move steadily along the seafloor, redistributing nutrients and shaping the distribution of organisms. The interaction between the sloping terrain and these currents creates zones where material tends to gather, forming areas of relative abundance within an otherwise sparse environment. Within this setting, biodiversity emerges in subtle but persistent ways. Species that are rarely seen elsewhere find suitable conditions along these slopes, adapted to the balance of depth, temperature, and available resources. The blobfish exists among a collection of organisms that share similar constraints, each shaped by the same underlying forces, yet expressing them in different forms. Crabs move slowly across the sediment, their paths leaving faint impressions that gradually fade. Brittle stars extend their arms across the surface, sensing minute changes in their surroundings. Sea cucumbers process the soft layers beneath them, extracting nourishment from what has settled over time. Each of these creatures occupies a specific role, contributing to a system that functions without rapid change or visible urgency. The slope supports these communities through its structure and position. It acts as a receiving ground for material descending from above, while also interacting with the slow movements of deeper waters. This combination allows nutrients to accumulate in ways that are not evenly distributed across the ocean floor. Certain areas become slightly richer than others, creating pockets where life can persist with greater consistency. This uneven distribution encourages specialization. Organisms adapt to the particular conditions of their immediate surroundings, leading to forms that may appear unusual when compared to those from more familiar environments. Reduced skeletal structures, softer tissues, and energy-conserving behaviors become common traits, not as anomalies, but as logical responses to the demands of this region. Despite its extent, the continental slope remains only partially understood. Its depth places it beyond the reach of most direct observation, and much of its complexity is inferred from limited data. Surveys provide glimpses, revealing patterns that suggest a rich and interconnected ecosystem, yet the full scope of its diversity remains largely hidden. The blobfish, within this context, is not an isolated curiosity, but part of a broader community shaped by the same conditions. Its presence along the slopes of Australia and New Zealand reflects the suitability of this environment, where balance, rather than abundance, defines survival. The terrain, the currents, and the gradual accumulation of resources all contribute to a setting where life persists quietly, adapting to a landscape that changes slowly over time. Here, along the long descent of the continental edge, the ocean reveals a different kind of richness, one that does not rely on visibility or intensity, but on the steady and enduring interaction between form and environment. Nothing grows here in the way it does nearer the surface. There are no fields of algae, no drifting forests of microscopic plants turning light into energy. The process that supports most life in the ocean, photosynthesis, fades away long before this depth is reached. Without light, it cannot occur, and without it, the foundation of the food web must take a different form. In place of growth, there is descent. Material produced far above begins a long, quiet journey downward, moving through layers of water over extended periods of time. This steady fall is often called marine snow, though it does not resemble the crystalline patterns of ice. Instead, it consists of countless particles, fragments of organic matter, microscopic remains, and tiny aggregates formed as these pieces clump together during their descent. Each particle travels slowly, drifting through the water column, sometimes caught in gentle currents that alter its path. As it moves deeper, it becomes part of a continuous rain, a soft and persistent transfer of energy from the sunlit layers to the depths below. By the time it reaches the seafloor, much of it has already been consumed or broken down, yet enough remains to support the organisms that depend on it. This falling material forms the base of life in this region. It settles across the terrain in thin, uneven layers, accumulating over time. Some of it is immediately consumed by small organisms that inhabit the sediment, while other portions remain available for longer periods, gradually becoming part of the environment itself. The blobfish, positioned just above this surface, exists within reach of this constant arrival, incorporating it into its pattern of feeding as it drifts past. The absence of photosynthesis means that energy must be conserved and used with care. There is no rapid replenishment, no sudden increase in available resources. Everything that arrives has traveled a long distance, and its quantity is limited by processes occurring far away. This creates a system where efficiency becomes essential, and where organisms are adapted to make use of what is present without excess. Connections between surface and depth remain unbroken, though they are not immediately visible. Events that occur in the upper ocean, such as blooms of microscopic life or the movements of larger animals, influence the amount and type of material that eventually reaches the seafloor. These changes are not felt instantly but unfold gradually, their effects carried downward over time. Within this system, life is sustained by continuity rather than abundance. The steady fall of marine snow provides a link between distant environments, allowing energy captured from sunlight to support organisms that never encounter it directly. Each particle represents a fragment of that distant process, transformed through its journey and integrated into a different context. The organisms that inhabit this depth are shaped by this dependence. Their behaviors, structures, and life cycles reflect the slow and consistent nature of their energy source. There is no need for rapid growth or frequent reproduction. Instead, survival is achieved through persistence, through the ability to endure within a system that changes only gradually. In this quiet exchange between layers of the ocean, the absence of light does not mean the absence of life. It marks a shift in how life is sustained, from direct interaction with sunlight to reliance on what descends from above. The blobfish exists within this flow, its presence tied to a process that begins far beyond its immediate surroundings, yet reaches it through the gentle and continuous fall of unseen fragments. Time does not pass here in the same way it does in brighter waters. It stretches, softens, and settles into a rhythm that feels unhurried, as if each moment is allowed to fully unfold before giving way to the next. Within this quiet tempo, life adjusts accordingly, shaping itself around a pace that favors endurance over speed. Deep-sea animals rarely move quickly, not because they cannot, but because there is little advantage in doing so. The environment offers few opportunities that reward sudden motion. Resources arrive slowly and unpredictably, and chasing them across distance would require more energy than they provide. Movement becomes measured, deliberate, and often minimal, guided by necessity rather than impulse. This restraint is closely tied to the availability of energy. In a setting where nourishment is limited and arrives only in scattered intervals, efficiency becomes essential. Every action must be balanced against its cost. Muscles are used sparingly, and the body is designed to function without constant activity. Even the simplest motion carries significance, and unnecessary effort is gradually reduced through adaptation. Metabolism reflects this same principle. Processes within the body operate at a slower rate, conserving energy over extended periods. Growth, digestion, and reproduction unfold gradually, aligned with the steady pace of the surrounding environment. There is no urgency to accelerate these cycles, as the conditions that support them remain stable over long durations. The blobfish exists within this framework of quiet conservation. Its movements are subtle, its presence steady, and its behavior shaped by the need to maintain balance with limited resources. It does not expend energy in frequent travel or rapid pursuit. Instead, it remains within a defined area, adjusting only when necessary, allowing the environment to bring what it requires. Across the deep ocean, similar patterns emerge in other species. Creatures that inhabit these depths often display reduced musculature and streamlined forms that support slow, sustained existence. Their bodies are not built for bursts of speed, but for persistence, capable of functioning over long intervals without significant input. This design allows them to endure in a place where energy is both scarce and unpredictable. With this slower pace comes an extension of lifespan. Many deep-sea organisms live longer than their counterparts in more dynamic environments. The reduced metabolic rate places less strain on their systems, allowing them to maintain function over extended periods. Growth may take years, and maturity may arrive gradually, but once established, these organisms can persist for decades. Reproduction follows this same pattern. Rather than frequent cycles, many species reproduce less often, investing more in each event. This approach aligns with the limited availability of resources, ensuring that energy is used carefully and effectively. Offspring are produced in ways that increase their chances of survival within the same slow and stable conditions. The surrounding environment supports this extended timeline. Without rapid fluctuations in temperature or light, there are fewer external pressures that demand quick adaptation. Stability allows life to proceed at a consistent pace, where change occurs gradually and over long periods. In this way, the deep ocean becomes a place where time itself feels expanded. Life does not rush or compete in the ways seen closer to the surface. Instead, it settles into a rhythm defined by patience, where each action is measured and each moment carries a quiet continuity. The blobfish, moving gently within this world, reflects that rhythm. Its existence is not marked by speed or intensity, but by a steady presence that aligns with the slow passage of time in the depths. A single image, captured in an unremarkable moment of handling, began a journey far beyond the conditions in which it was taken. It did not originate as a carefully composed portrait or a deliberate attempt to represent a species. Instead, it emerged from the routine process of documenting a specimen brought to the surface, its form already altered, its structure no longer aligned with the environment that had shaped it. The photograph revealed a figure that seemed unfamiliar even within the wide range of known marine life. Its features appeared softened and uneven, its contours lacking the definition that observers often expect from a fish. There was no context provided alongside it, no explanation of the depth from which it came or the changes it had undergone. It existed as a single frame, isolated from the conditions that had given it form. From there, the image moved outward, first through small circles of scientific and academic exchange, then into broader channels where its unusual appearance drew attention. As it traveled, it became separated from its original setting, shared and reshared without the accompanying details that might have framed it differently. Its path followed the growing networks of the internet, where images could spread rapidly, carried by curiosity and repetition. In these spaces, the photograph began to take on a different role. It was no longer a record of a specimen, but a subject of commentary, its appearance interpreted through a human lens that sought familiarity and expression. Descriptions formed around it, often emphasizing its perceived strangeness, assigning it a place among the most unusual creatures known to the public. The absence of context allowed these interpretations to settle, shaping how the image was understood. As more people encountered it, the photograph became a point of recognition. It appeared in articles, collections of unusual animals, and later in the expanding culture of online sharing. Each repetition reinforced its identity, transforming it from an obscure scientific image into a widely recognized symbol. Its features, though altered from their original state, became the defining representation of the species in the public imagination. This shift occurred gradually, yet its effects were far-reaching. The blobfish, once known only through limited scientific observation, became a familiar figure across the world. Its image crossed languages and regions, appearing in contexts far removed from marine biology. It was discussed, interpreted, and reinterpreted, each iteration adding another layer to its public identity. The spread of the photograph also highlighted the changing relationship between science and visibility. In earlier times, such an image might have remained within specialized circles, its significance limited to those studying the deep ocean. With the expansion of digital communication, it reached a much wider audience, one that engaged with it in ways that differed from its original purpose. Without the surrounding explanation, the image stood on its own, inviting interpretation based solely on what was visible. The conditions that had shaped its appearance remained unseen, and so the photograph came to represent not the living organism in its environment, but a moment removed from it. This distinction, though subtle, influenced how the blobfish was perceived on a global scale. Over time, the image became one of the most recognizable representations of deep-sea life, not because it accurately depicted the organism as it exists, but because it resonated within the structures of modern communication. Its familiarity grew through repetition, and with that familiarity came a simplified understanding, one that focused on appearance rather than context. In this way, A single photograph, taken without intention of widespread attention, moved through layers of interpretation until it became a defining image. It carried with it only part of the story, leaving the rest to remain quietly beneath the surface, where the original form of the blobfish continues to exist beyond the frame. The moment of ascent begins long before the surface is reached. As a deep-sea fish is carried upward, the surrounding water changes in ways that are invisible yet profound, altering the forces that have always held its body in balance. What was once a stable equilibrium begins to shift, not suddenly, but with a steady progression that unfolds over the course of the journey. Pressure decreases continuously during this ascent. Each meter upward reduces the weight pressing inward, easing a force that had remained constant throughout the animal's life. For organisms adapted to that constant compression, this change is not a release in the way it might seem. Instead, it disrupts the internal balance that has been maintained under high pressure, allowing structures that were once held in place to begin expanding. In species that contain gas-filled spaces, this effect becomes especially pronounced. Gases respond quickly to changes in pressure, increasing in volume as the surrounding force diminishes. Organs that rely on controlled gas levels begin to swell, their internal volumes expanding beyond their usual limits. This expansion places strain on surrounding tissues, altering their shape and position within the body. Even in organisms with reduced gas content, the effects of decompression are significant. Tissues that developed under high pressure are structured to function within that environment. Proteins, membranes, and fluids are all arranged in ways that depend on the external force remaining constant. As that force lessens, these structures can begin to behave differently, losing the stability that once defined them. The body of a deep-sea fish is not built to resist outward expansion. Its form reflects a long adaptation to inward pressure, and when that pressure is removed, the balance shifts. Cells may stretch, internal fluids redistribute, and the overall structure begins to change. What was once a cohesive shape becomes altered, its features softening or distorting in response to the new conditions. For the blobfish, this transformation is particularly noticeable. Its gelatinous body, so carefully aligned with the density and pressure of its environment, no longer experiences the same forces that gave it form. Without the surrounding compression, its tissues lose the support that helped maintain their structure. The result is a visible change in shape, one that appears unfamiliar when compared to its original state. This process does not occur as a single event, but as a gradual sequence. As the fish rises, each stage of decompression contributes to the overall transformation. By the time it reaches the surface, the cumulative effect of these changes has altered its appearance significantly. What is observed at that point is not the organism as it existed in its natural environment, but a version shaped by the conditions of ascent. The collapse often described is not a sudden failure, but the outcome of this continuous shift in pressure. Without the external force that once balanced its internal structure, the body settles into a different form. Tissues that were once supported become less defined, and the overall shape reflects the absence of the environment it depended on. This transformation highlights the deep connection between these organisms and the conditions in which they evolved. Their bodies are not independent of their surroundings, but closely integrated with them. When removed from that context, the relationship changes, and the form that emerges is one that cannot fully represent the original state. In this way, the ascent to the surface becomes more than a change in location. It is a transition between entirely different sets of conditions, each with its own demands. The deep-sea fish, shaped by one, cannot remain unchanged within the other, and the differences become visible in the form it takes once the journey is complete. Seen where it belongs, the blobfish does not appear as a collapsed form, but as a balanced one, its shape held in quiet alignment with the surrounding water. The soft contours that seem irregular at the surface take on a different coherence at depth. Its body becomes more defined, gently rounded rather than sagging, with features that settle into place under the steady conditions of its environment. Scientists have come to understand this appearance not through direct and prolonged observation, but through a combination of evidence gathered over time. Deep-sea cameras, lowered into these depths or carried by remote vehicles, have provided brief glimpses of the blobfish in motion. These encounters are often fleeting, captured in low light and at a distance, yet they reveal an organism that maintains a consistent form, moving with subtle adjustments rather than dramatic shifts. In these recordings, the blobfish appears slightly buoyant, its body held just above the seafloor without strain. Its surface looks smooth and intact, lacking the pronounced deformation seen in specimens brought upward. The head retains a gentle structure, and the features that seem exaggerated at the surface are less distinct, integrated into a more uniform outline. Movement is minimal, consisting of small fin motions that maintain position rather than propel it across distance. These observations are supported by comparisons with preserved specimens that have been carefully studied. While preservation can alter certain characteristics, it allows researchers to examine the underlying anatomy without the additional distortions caused by rapid ascent. In these controlled conditions, the blobfish reveals proportions that are more consistent with what is seen in deep-sea footage. The body appears fuller, its tissues arranged in a way that suggests stability rather than collapse. Differences between preserved and surface-caught specimens highlight the role of environmental conditions in shaping appearance. When a blobfish is brought to the surface, the changes it undergoes obscure its original form. In contrast, specimens that are handled with greater care, or observed through non-invasive methods, retain features that more closely resemble their natural state. These comparisons provide a clearer picture of how the organism exists in its own environment. The texture of the body also appears different under natural conditions. Instead of the uneven and drooping surface often associated with its image, the skin seems more cohesive, with a consistent thickness that supports its overall shape. This cohesion is not the result of rigidity, but of balance, maintained by the surrounding pressure that holds the tissues in place. Lighting in deep-sea observations is limited and artificial, yet it reveals enough to suggest coloration and surface detail. The blobfish often appears pale, with subtle variations in tone rather than strong contrasts. This muted appearance blends with the surrounding environment, offering no sharp edges or distinct patterns. Its presence is quiet, integrated into the landscape rather than standing apart from it. Through these combined sources, camera observations, careful examination of specimens, and an understanding of the conditions at depth, scientists have formed a more accurate impression of the blobfish as it exists naturally. It is not a formless anomaly, but a creature whose structure reflects the environment that supports it. The difference between these views is not a contradiction, but a shift in perspective shaped by context. When seen within its proper setting, the blobfish presents a form that is stable, functional, and consistent, its appearance aligned with the conditions that have shaped it over time. Adaptation in the deep ocean does not arrive as a dramatic transformation, but as a gradual refinement shaped over long stretches of time by conditions that rarely change. Each feature that persists has done so because it aligns precisely with the forces present at depth, where survival depends less on strength and more on compatibility with the surrounding environment. One of the most distinctive outcomes of this process is the development of gelatinous body structures. These tissues, composed largely of water with a loose network of supportive material, behave differently from the denser forms found in many other animals. Under high pressure, such a composition allows the body to remain stable without requiring rigid support. The external force acts evenly across the organism, and because the internal structure offers little resistance, there are fewer points of strain. Rather than being compressed unevenly, the body maintains its integrity through uniform distribution of pressure. This quality becomes especially important in an environment where pressure remains constant and intense. A more rigid structure might resist deformation in one context, yet under sustained compression, it can develop weaknesses, areas where stress accumulates. Gelatinous tissues avoid this by yielding slightly, accommodating the surrounding force instead of opposing it. The result is a form that remains cohesive without the need for heavy reinforcement. Bone density follows a similar pattern of adjustment. In many deep-sea species, skeletal elements are reduced in both mass and thickness. This does not mean the skeleton is absent, but that it is refined to provide only the necessary support. Heavy, dense bones would increase overall weight and require more energy to maintain position within the water. By reducing density, the organism achieves a closer balance with its surroundings, minimizing the effort needed to remain stable. This reduction also reflects the absence of forces that would otherwise demand stronger structures. In shallower environments, movement, predation, and interaction with currents often require a robust framework. At depth, where motion is limited and interactions are less frequent, such reinforcement becomes less essential. The skeleton evolves to match these conditions, retaining functionality while shedding excess mass. Musculature undergoes a comparable transformation. Instead of large, powerful muscle groups designed for rapid movement, deep-sea organisms develop smaller, less energy-demanding systems. These muscles are sufficient for gentle adjustments and slow repositioning, but they do not support sustained or high-speed activity. This is not a limitation, but a reflection of the environment where energy must be conserved and where rapid motion offers little advantage. The combination of gelatinous tissues, reduced bone density, and minimal muscle structure creates a body that is finely tuned to its surroundings. Each component contributes to an overall efficiency, allowing the organism to exist with minimal expenditure. Energy that might otherwise be used for maintaining heavy structures or supporting constant movement is instead conserved, supporting long-term survival in a resource-limited setting. These adaptations also influence how internal systems function. Circulation, respiration, and cellular processes are all aligned with the reduced pace of life at depth. There is no need for rapid delivery of oxygen or nutrients, as the demands of the body remain low. Everything operates within a steady range, consistent with the stable conditions of the environment. Over generations, these traits become more pronounced, shaped by the selective pressures of the deep ocean. What remains is a form that may appear unusual when compared to organisms from more dynamic habitats, yet is precisely suited to its own. The blobfish embodies this balance, its structure reflecting a long process of adaptation that favors harmony with pressure over resistance. In this quiet alignment, the science of deep-sea adaptation reveals a principle that extends beyond a single species. Life persists, not by opposing its environment, but by gradually becoming part of it, shaped by forces that remain constant across time. Across spans of time that extend far beyond human perception, the deep ocean has remained a place of remarkable consistency. Its conditions shift only gradually, allowing evolutionary change to unfold in slow and deliberate ways. Within this stability, organisms do not need to adapt quickly to sudden variation, but instead refine their forms across millions of years, each generation adjusting in small increments that accumulate into lasting transformation. The blobfish is part of this long process, its characteristics shaped by an environment that imposes very specific demands. Over extended periods, features that align with these demands are preserved, while those that do not gradually fade. The result is not a dramatic redesign, but a quiet tuning of structure and function, guided by the steady influence of depth, pressure, and limited energy. In such an environment, anatomy evolves toward efficiency and balance. Structures that require constant energy to maintain become less prominent, while those that support stability with minimal effort are favored. The body becomes an expression of its surroundings, shaped by forces that operate continuously rather than intermittently. This leads to forms that may appear unusual when compared to life in more variable conditions, yet are precisely suited to their own context. Deep sea conditions create a set of evolutionary pressures that differ from those found closer to the surface. There is no reliance on light, no need for rapid movement across large distances, and no abundance of resources that would support frequent growth or reproduction. Instead, survival depends on the ability to persist, to function steadily within a narrow range of conditions over long periods of time. Predation exists, but it often occurs at a slower pace, shaped by the same limitations that influence all life at depth. Encounters between organisms are less frequent, and the need for constant vigilance or rapid escape is reduced. This allows for a different balance between defensive structures and energy conservation. Features that would be essential in more dynamic environments may become less pronounced, replaced by adaptations that support endurance. Reproductive strategies also reflect these conditions. With fewer opportunities and limited resources, many deep-sea species invest in approaches that increase the likelihood of long-term survival rather than immediate abundance. Offspring may develop slowly, maturing over extended periods before contributing to the next generation. This gradual cycle aligns with the overall pace of the environment, where change is measured in decades rather than moments. The absence of frequent disturbance allows evolutionary changes to become deeply embedded within populations. Traits that prove effective remain stable across long stretches of time, leading to lineages that exhibit a strong continuity of form. At the same time, the isolation of different regions within the deep ocean can lead to divergence as populations adapt to slightly varying conditions along the seafloor. Within this framework, the blobfish represents a convergence of multiple adaptive pathways. Its structure reflects not a single change, but a series of adjustments that together create a form suited to its environment. Each feature, from its composition to its behavior, is the result of countless generations responding to the same underlying pressures. Evolution in the deep ocean does not produce forms that strive for speed or dominance. Instead, it favors those that can exist quietly within their surroundings, maintaining function with minimal strain. Over millions of years, this process shapes organisms that embody the conditions in which they live, their forms becoming inseparable from the environment that defines them. In this slow unfolding of change, the deep sea reveals a different expression of evolution, one that emphasizes continuity, efficiency, and a steady alignment with forces that remain constant across time. Classification in this context emerges not as a label, but as a quiet recognition of shared design. The blobfish belongs to a group known as the cycrolutids, a family of fishes that inhabit cold, deep waters across different regions of the world. Within this family, individual species vary in form and distribution, yet they carry a set of underlying traits that reflect a common response to similar environmental conditions. Cycrolutids are often referred to as fathead sculpins, a name that hints at the proportions seen across many members of the group. Their heads tend to be broad and rounded, their bodies tapering gradually, with features that appear softened when compared to more rigidly structured fish. This overall shape is not incidental, but closely tied to the demands of the environments they occupy, where balance and efficiency take precedence over speed or agility. Across the family, species are found in deep, cold regions of the ocean, often along continental slopes and in areas where conditions remain stable over long periods. These habitats share characteristics that influence how these fish have evolved, including low temperatures, limited food availability, and the persistent influence of pressure. Each species within the cycrolutids reflects these conditions in its own way, yet the similarities between them reveal a shared evolutionary pathway. The blobfish represents one expression of this broader pattern. Other related species display variations in body shape and texture, some appearing slightly firmer, others more streamlined, yet all maintaining a general softness that distinguishes them from many shallow water fish. Their bodies often lack strong, rigid outlines, instead presenting forms that are subtly contoured and well suited to the density of the water around them. Reduced skeletal structure is a common feature within the family. Bones are present, providing necessary support, but they are lighter and less dense than those found in more active species. This reduction aligns with the need to conserve energy and maintain stability without excessive effort. Similarly, musculature tends to be modest, sufficient for slow and controlled movement rather than sustained activity. Fins among cycrolutids are typically small and adapted for gentle adjustments rather than propulsion over long distances. These structures allow the fish to maintain orientation and position within their environment, responding to subtle shifts without requiring significant exertion. The overall effect is a mode of existence that emphasizes continuity and balance. Coloration within the family is often muted, reflecting the absence of light in their habitats. Shades tend toward pale or subdued tones, blending with the surrounding environment rather than standing out against it. This lack of contrast is not a form of concealment in the traditional sense, but a natural outcome of living in conditions where visibility is limited. Despite these shared traits, diversity within the cycrolutids remains evident. Species differ in size, distribution, and specific adaptations, reflecting the variations present within their respective environments. Some inhabit slightly shallower regions, while others extend into greater depths, each adjusting to the conditions they encounter. The classification of the blobfish within this family provides context for its form and behavior. It is not an isolated anomaly, but part of a lineage shaped by similar pressures over long periods. Its characteristics, when viewed alongside those of related species, reveal a consistent pattern of adaptation, one that reflects the broader dynamics of life in cold, deep waters. Within this family, the blobfish finds its place not through distinction alone, but through connection, sharing a set of traits that have been refined across generations, each contributing to a form that aligns with the quiet demands of its environment. Reproduction, in this depth, unfolds quietly against the seafloor, without the visible signals or rapid cycles seen in more illuminated environments. The continuation of a species depends on careful timing and placement, where each decision carries weight in a setting defined by limited resources and long intervals between opportunity. Within this stillness, certain behaviors emerge that suggest a more deliberate approach to ensuring the survival of the next generation. Among these is the observation that blobfish appear to guard their eggs, remaining close to them after they have been laid. Evidence gathered from deep-sea imaging has shown individuals positioned over clusters of eggs, their bodies resting just above the sediment, maintaining a steady presence. This behavior does not involve active defense in the sense seen in faster-moving species, but rather a form of quiet protection, where proximity itself becomes the primary safeguard. The eggs are typically laid on the seafloor, nestled within soft sediments that provide a stable surface. These deposits allow the eggs to remain in place, reducing the likelihood that they will be displaced by the slow but persistent movement of water. The location is not chosen at random. Subtle variations in the terrain, slight depressions or areas where material has accumulated can offer additional stability, creating a setting where the eggs can develop with minimal disturbance. Once deposited, the eggs remain exposed to the surrounding environment, subject to the same conditions that define all life at this depth. Without the presence of sunlight or strong currents, the risks they face are different from those encountered in shallower waters. Predation still exists, but encounters are less frequent, and the slow pace of the environment reduces the likelihood of sudden disruption. Even so, the presence of a guarding adult adds an additional layer of security, discouraging smaller organisms that might otherwise approach. The act of guarding requires energy, though it is expressed in stillness rather than motion. The adult remains in close contact with the eggs, adjusting its position only slightly to maintain coverage. This sustained presence reflects a trade-off, where time and energy are invested in a single reproductive event rather than distributed across multiple attempts. In an environment where opportunities are limited, this focused investment increases the chances that at least some offspring will reach maturity. Development proceeds gradually. The eggs remain in place over extended periods, their growth aligned with the slow pace of the surrounding conditions. There is no rapid transformation, no sudden emergence. Instead, each stage unfolds in sequence, supported by the stability of the environment and the continued presence of the guarding adult. This form of parental care represents a shift from strategies that rely on large numbers of offspring with minimal oversight. In the deep ocean, producing fewer eggs and protecting them more carefully can be a more effective approach. The balance between quantity and survival shifts, favoring methods that increase the likelihood of success for each individual rather than relying on chance. The blobfish, through this behavior, becomes part of a broader pattern seen among certain deep-sea species. While not all organisms in these environments provide care for their young, those that do reflect an adaptation to the specific challenges of life at depth. The quiet act of remaining near a cluster of eggs, maintaining a steady presence over time, aligns with the overall rhythm of the environment, where persistence and stability guide survival. In this still and dimly lit world, the continuation of life depends not on rapid cycles or visible displays, but on careful placement and patient guardianship, where even the smallest actions contribute to the unfolding of the next generation. Across this depth, the seafloor extends in long, uninterrupted stretches, where detail is measured in subtle shifts rather than sharp contrasts. The landscape does not rise dramatically or break into sudden forms. Instead, it unfolds gradually, shaped by the steady accumulation of fine sediments that settle over time, layer upon layer, forming a surface that appears almost continuous. These vast muddy plains dominate much of the terrain. The sediment, composed of minute particles that have traveled from distant regions, creates a soft and uniform covering across the ground. It yields slightly under contact, holding impressions for a time before they fade back into the surrounding surface. There is no clear boundary between one area and the next, only gentle variations in texture and depth that emerge over long distances. Movement across this terrain leaves only temporary traces. A passing organism may disturb the upper layer, creating faint patterns that persist for a while before being softened by the gradual settling of new material. Over time, the surface restores itself, returning to its quiet uniformity. This continual process of disturbance and renewal occurs slowly, without abrupt change, maintaining a sense of continuity across the landscape. Within this broad expanse, rock formations appear only occasionally, rising from the sediment as isolated structures. These outcrops vary in size and shape, some forming low ridges, others standing as scattered fragments that interrupt the otherwise smooth terrain. Their presence introduces a degree of variation, offering points of contrast within an environment that is otherwise defined by its consistency. The surfaces of these rocks differ from the surrounding sediment. They provide firmer ground, supporting organisms that require a more stable attachment point. Over time, they can become centers of localized activity, where life gathers in small clusters, taking advantage of the slight differences in structure. Yet even here, the overall pace remains slow, and the presence of these formations does not disrupt the broader stillness of the environment. Between these scattered features, the plains continue, extending beyond immediate view. The absence of strong currents or frequent disturbances allows the landscape to remain largely undisturbed over long periods. This stability shapes not only the physical terrain, but also the patterns of life that inhabit it. Organisms adapt to a setting where change is gradual, where the environment remains consistent enough to support long-term persistence. The stillness of the seafloor is not an absence of activity, but a different expression of it. Processes continue at a pace that is almost imperceptible, unfolding over extended periods. Sediments settle, organisms move slowly across the surface, and interactions occur without urgency. The landscape reflects this rhythm, its features shaped by forces that operate steadily rather than suddenly. Sound, as it is commonly understood, does not carry in the same way here. The environment lacks the constant motion that generates noise in shallower waters. Instead, there is a sense of quiet that accompanies the stability of the surroundings. Vibrations are minimal, and the overall impression is one of calm, where the absence of rapid change creates a continuous, unbroken atmosphere. Within this setting, the blobfish exists as part of the landscape, its presence aligned with the contours of the seafloor. It does not stand apart from its surroundings, but blends into them, its form and behavior reflecting the same steady conditions that define the terrain. The muddy plains, the occasional rock formations, and the quiet stillness all contribute to a world where life persists without urgency, shaped by a landscape that changes only in the most gradual of ways. Around the blobfish, the seafloor is never truly empty. It is inhabited by a quiet assembly of organisms, each moving within its own narrow range, each shaped by the same conditions that define this depth. Their presence does not create a sense of activity in the usual way, but rather a dispersed and subtle pattern where life reveals itself gradually through small and deliberate motions. Deep sea crabs move across the sediment with a steady and measured pace. Their limbs press lightly into the soft surface, leaving faint impressions that linger before slowly fading. These crabs do not travel far in short periods, instead navigating the terrain in careful increments, guided by chemical signals and slight variations in the environment. Their bodies are adapted to the pressure and cold, their movements efficient, conserving energy while still allowing them to search for food within a limited area. Nearby, brittle stars extend their arms outward, their bodies anchored at a central point, while their flexible limbs explore the surrounding space. These arms move with a gentle coordination, responding to subtle cues in the water and along the seafloor. Rather than relocating entirely, brittle stars often remain in place, gathering what drifts within reach. Their structure allows them to cover a wider area without expending the energy required for full movement, an adaptation that aligns with the steady conditions of their environment. Sea cucumbers contribute to a different aspect of this ecosystem. They move slowly across the sediment, processing the material beneath them as they go. Their bodies, elongated and soft, glide along the surface, taking in the upper layers of the seafloor and extracting the organic components within. This continuous feeding reshapes the sediment over time, creating subtle patterns that reflect their passage. Their role is less about movement and more about transformation, turning settled material into a usable form of energy. Among these organisms are also predators, though their presence is expressed without urgency. They do not pursue prey over long distances or rely on sudden bursts of speed. Instead, they move with the same measured pace as the rest of the community, relying on proximity and timing. Some remain partially concealed within the sediment, while others drift slowly, adjusting their position in response to the faint signals of nearby movement. Encounters between predator and prey occur within this shared rhythm, shaped by the limitations of the environment. There are no rapid chases or dramatic interactions. Instead, these moments unfold quietly, often determined by chance as much as by intention. The outcome depends on subtle differences in position and awareness, rather than on strength or speed alone. Each of these creatures occupies a specific role within the broader system, contributing to a balance that is maintained through continuity rather than competition. The crab's slow search, the brittle star's extended reach, the sea cucumber's steady processing, and the predator's patient presence all form part of an interconnected pattern. No single element dominates, and no action disrupts the overall stillness. The blobfish exists among them without standing apart. Its behavior aligns with the same principles, its movements as restrained as those of its neighbors. It does not interact with them frequently, yet its presence is part of the same environment, shaped by the same forces that guide their existence. Within this shared world, life unfolds through quiet coexistence. Each organism moves within its own pace, contributing to a landscape where activity is subtle and persistent. The seafloor becomes a place not of isolation, but of dispersed and continuous presence, where different forms of life exist side by side, connected by the slow and steady rhythms of the deep ocean. Far below the surface, where motion seems absent, the ocean continues to move in ways that are subtle and far-reaching. The water here is never completely still. It shifts slowly, guided by differences in temperature and salinity that form vast, interconnected pathways stretching across entire ocean basins. These movements are not easily seen, yet they shape the distribution of life with a steady and persistent influence. The driving forces behind these currents originate far from the depths themselves. In colder regions near the poles, surface water becomes denser as it cools and increases in salinity. This heavier water begins to sink, initiating a downward flow that contributes to the larger system of deep ocean circulation. Once below, it spreads outward, moving along the contours of the seafloor in broad, slow currents that can take years or even centuries to complete their journey. As this water travels, it carries with it dissolved nutrients and fine organic particles that have entered the ocean at different points along its path. These materials are distributed across large distances, reaching areas that are otherwise isolated from direct input. The currents act as quiet conveyors, delivering resources in a gradual and continuous manner, allowing life to persist in places where local production is limited. Closer to the seafloor, the movement of water becomes influenced by the shape of the terrain. The continental slope, with its gentle descent and occasional ridges, directs the flow into specific patterns. In some areas, water moves along the slope, following its contours in a steady drift. In others, it may be deflected upward or downward, creating localized variations in movement. These subtle changes affect how nutrients are deposited, leading to differences in availability across relatively small distances. For organisms living at these depths, these currents provide a connection to distant processes. Material that originated far above or far away is carried into their environment, arriving gradually through the movement of water. The blobfish, positioned within this system, benefits from these flows without needing to travel. Its placement allows it to receive what the currents bring, integrating its behavior with the movement of the surrounding water. The pace of these currents is slow, often measured in centimeters per second, yet their effects accumulate over time. They shape the distribution of sediments, influence the availability of food, and contribute to the overall stability of the environment. Unlike surface currents, which can change rapidly with weather and seasonal variation, deep ocean currents remain consistent, forming part of a larger, global circulation pattern. This global system, sometimes referred to as thermohaline circulation, links the oceans into a continuous network. Water that sinks in one region may eventually rise in another, completing a cycle that spans vast distances. Along this path, it carries not only nutrients, but also heat and dissolved gases, contributing to the balance of the entire ocean. Within this network, the deep sea is not isolated, but connected through slow and enduring movement. The currents provide a means of exchange, linking distant environments in a process that unfolds over extended periods. Each part of the system influences the others, creating a dynamic that remains steady despite its scale. In this way, the deep ocean reveals a form of motion that is quiet yet essential. The water moves without urgency, its pathways shaped by forces that operate over long timescales. Through this movement, resources are distributed, and life is sustained, not through rapid change, but through the continuous and gentle flow that defines the hidden currents of the deep. Observation in the deep ocean is shaped as much by distance as by darkness. The world where the blobfish exists lies far beyond the reach of ordinary tools, separated from the surface by layers of water that limit access in both space and time. To reach it requires more than simple descent. It demands equipment capable of enduring conditions that place constant strain on materials and systems alike. Studying life at these depths begins with overcoming that separation. Human presence is not possible without protection, and so exploration depends on submersibles and remotely operated vehicles, machines designed to carry instruments into environments that would otherwise remain inaccessible. These vehicles must withstand immense external forces while maintaining precise control, allowing them to move carefully across the seafloor without disturbing the surroundings they are meant to observe. The development and operation of such technology involves significant resources. Each expedition requires careful planning, specialized crews, and vessels capable of supporting extended deployments. The cost of building and maintaining deep-sea vehicles is substantial, and their use is often limited to short periods of time. As a result, opportunities to observe deep-sea organisms directly are rare and carefully allocated. Even when these tools reach the seafloor, observation remains constrained. The field of view is narrow, defined by the range of cameras and lights that can be carried into the depths. Illumination is artificial and limited, revealing only small portions of the environment at any given moment. Beyond that illuminated area, the landscape remains unseen, extending into darkness that cannot be easily penetrated. The presence of the vehicle itself can influence what is observed. Lights and movement may alter the behavior of nearby organisms, causing them to retreat or remain still. Sound and vibration, though reduced, can also affect how animals respond. These factors introduce a level of uncertainty, as what is recorded may not fully represent natural behavior under undisturbed conditions. For the blobfish, these limitations are especially significant. Its movements are subtle, its behavior defined by stillness and slow response. Capturing these qualities requires extended observation, yet the time available during any single deployment is limited. As a result, most encounters with the species are brief, offering only partial glimpses of its natural activity. Indirect methods provide additional insight, though they come with their own constraints. Specimens collected through trawling offer opportunities for detailed study, but as noted earlier, the process of retrieval alters their form. Observations made from these specimens must be interpreted carefully, taking into account the changes that occur during ascent. Advances in technology have begun to expand the possibilities for study. Improved camera systems, longer-lasting deployments, and more precise navigation allow researchers to gather data with greater accuracy than before. Autonomous vehicles can remain at depth for extended periods, recording continuous footage that reveals patterns not visible in shorter observations. Even so, the scale of the environment means that much remains beyond direct observation. Data collected from these efforts is often fragmentary, requiring careful analysis and integration. Patterns are identified over time, built from multiple observations that together form a more complete picture. The behavior of the blobfish, like that of many deep-sea organisms, is understood through this gradual accumulation of evidence rather than through continuous study. In this way, the challenges of studying deep-sea life shape the knowledge that emerges. Each observation carries weight, not because it is comprehensive, but because it contributes to a larger understanding built piece by piece. The environment resists easy access, and so learning proceeds slowly, guided by the same patience that defines life within it. Discovery, in the deep ocean, has often arrived without intention. Long before targeted exploration reached these depths, large nets were lowered for entirely different purposes, drawn across the seafloor to gather species of commercial interest. In the process, they collected far more than what they were designed to catch, lifting unfamiliar forms from environments that had remained undisturbed for long periods. Many of the first recorded blobfish specimens came from these trawling operations. As nets moved slowly along the bottom, they swept through the soft sediment and the organisms living just above it. Among the expected catch, there would occasionally appear a form that did not match known categories, its features altered by the journey upward. These encounters were not frequent, but they occurred often enough to suggest that the species was part of a broader community rather than an isolated rarity. The method itself shaped what was discovered. Trawling nets cover wide areas, collecting whatever lies in their path, but they do so without precision. Organisms are gathered together, removed from their positions, and brought to the surface in a state that reflects the process rather than their natural condition. For species like the blobfish, this means that the first impressions available to researchers were influenced by the effects of capture and ascent. At the same time, this method provided access to environments that were otherwise difficult to study. Without these early collections, many deep-sea species might have remained unknown for much longer. The material brought up in nets offered a starting point, allowing scientists to begin identifying patterns and relationships among organisms that shared similar habitats. Yet, the process carries consequences that extend beyond discovery. As nets move across the seafloor, they interact directly with the landscape, disturbing the sediment and the structures within it. The soft layers that accumulate over time are displaced, and the organisms that depend on them are disrupted. Tracks left by these operations can persist, altering the surface in ways that take long periods to recover. Fragile habitats are particularly affected. Areas where organisms have established themselves around subtle features, such as slight variations in the terrain or the presence of small structures, can be changed significantly by the passage of a net. The balance within these communities depends on stability, and even minor disturbances can shift how resources are distributed. For species adapted to slow movement and limited energy use, recovery from such disturbance is not immediate. The pace of life at depth means that changes unfold gradually, and restoration of the original conditions may take extended periods. In this context, the impact of trawling is not only physical, but temporal, altering environments that evolve over long timescales. The blobfish, encountered through this process, becomes part of a broader narrative of accidental discovery. Its presence in trawl samples reflects both the reach of these methods and their limitations. While they reveal the existence of species that would otherwise remain unseen, they also present those species in forms that do not fully represent their natural state. Over time, awareness of these effects has influenced how deep-sea environments are approached. There is a growing recognition that methods of study must balance the need for knowledge with the preservation of the systems being observed. The early reliance on trawling provided valuable information, yet it also highlighted the sensitivity of these habitats. Within this history, the blobfish stands as both a subject of discovery and a reminder of the conditions under which that discovery occurred. Its appearance in nets marked the beginning of a broader understanding, even as it reflected the challenges of observing life in a place where direct access remains limited. To an eye shaped by surface conditions, deep-sea creatures often appear unfamiliar, their forms lacking the symmetry and firmness that seem expected. This impression does not arise from disorder, but from a different set of priorities, where structure is guided by constraints that are rarely encountered elsewhere. What seems unusual is often the result of careful adjustment, shaped by trade-offs that favor survival under constant pressure and limited energy. In these depths, every feature carries a cost. Maintaining dense bone, strong muscle, or complex sensory systems requires energy that may not always be available. Over time, evolution favors forms that reduce these costs while still allowing essential functions to continue. This process does not remove structure entirely, but refines it, keeping only what is necessary for stability and interaction within the environment. Reduced skeletons are one outcome of this refinement. Instead of heavy frameworks designed to support rapid movement or resist strong external forces, Many deep-sea species develop lighter internal structures. Bones become thinner, less dense, and sometimes partially replaced by softer materials. This reduction lowers the energy required to maintain the body and helps align its overall density with the surrounding water, contributing to a stable position without constant effort. Muscle mass follows a similar pattern, though its reduction is not simply a matter of absence. Muscles remain present, but they are adapted for slow and controlled movement rather than speed or strength. This adjustment reflects the limited need for rapid motion, as the environment does not demand frequent bursts of activity. Energy is conserved by minimizing unnecessary exertion, allowing the organism to persist over long periods with fewer resources. These structural changes lead to shapes that may appear irregular or less defined when compared to those of more active species. Bodies can seem softer, contours less rigid, and proportions different from familiar patterns. Yet each of these characteristics serves a purpose, allowing the organism to exist in balance with the forces around it. The absence of sharp definition is not a flaw, but an adaptation to a setting where flexibility and even distribution of pressure are more effective than rigidity. The concept of evolutionary trade-offs becomes central in understanding these forms. Gains in one area often require reductions in another, and the balance achieved reflects the specific demands of the environment. In the deep ocean, where energy is scarce and pressure is constant, the advantages of reduced structure outweigh the benefits of strength or speed. The resulting shapes reflect this balance, embodying a compromise that supports long-term survival. When these organisms are observed outside their natural conditions, their appearance can seem exaggerated or distorted. Without the surrounding pressure that helps maintain their structure, softer tissues may lose their shape, and the features that once aligned with the environment appear unfamiliar. This difference highlights how closely their form is tied to the conditions in which they evolved. Understanding these adaptations requires a shift in perspective, recognizing that what appears unusual is often precisely suited to its context. The shapes of deep-sea creatures are not random, but the outcome of millions of years of gradual adjustment, each change contributing to a form that works within a specific set of constraints. The blobfish, like many others in this environment, reflects these principles. Its appearance, when seen within its proper setting, aligns with the same logic that shapes other deep-sea organisms. Reduced skeletal support, minimal musculature, and a body that accommodates pressure all contribute to a form that may seem unfamiliar at first glance, yet reveals its purpose through careful observation. In this way, the perceived strangeness of deep sea life becomes an expression of adaptation, where each feature is shaped by trade-offs that allow existence to continue in a world defined by quiet and constant forces. A form observed outside its proper setting carries traces of a journey that reshaped it. When deep sea animals are brought upward, their appearance reflects not only their biology, but the conditions they have passed through. What is seen at the surface is often a transformed version, shaped by changes that begin long before the ascent is complete. Pressure plays a central role in this transformation. At depth, the body exists within a constant external force that supports and stabilizes its structure. As that force diminishes during ascent, the balance between internal and external conditions begins to shift. Tissues that were once held in place by surrounding pressure experience a release that alters their arrangement, allowing them to expand or settle in new ways. This change affects different parts of the body in different ways. In species that contain gases, expansion can occur rapidly, increasing volume and altering proportions. In others, where gases are minimal, the effects are more gradual, yet still significant. Soft tissues may lose their cohesion, spreading slightly as the external support is removed. The overall form becomes less defined, its features appearing altered when compared to their original state. These changes are not the result of damage in the conventional sense, but of a shift in equilibrium. The body has evolved to function within a specific range of pressure, and when that range is no longer present, its structure adjusts accordingly. The appearance that emerges at the surface is therefore a reflection of new conditions, rather than a direct representation of the organism as it exists in its natural environment. The blobfish provides a clear example of this process. Its form, when observed at depth, maintains a consistent shape that aligns with the surrounding pressure. Once brought upward, that same body undergoes a visible transformation. Features that were once integrated into a stable structure become more pronounced or displaced, creating an appearance that differs from its original form. This difference can lead to misinterpretation. Without an understanding of the role pressure plays, the surface appearance may be taken as the true representation of the species. In reality, it reflects only a moment after a significant change has occurred. The original structure, shaped by the conditions of the deep ocean, is no longer fully visible in that state. Other deep-sea species experience similar transformations. Bodies that appear firm at depth may seem softened, while those that rely on precise internal balance may show altered proportions. These variations are consistent with the changes in pressure and do not indicate unusual or defective forms within their natural context. Tissue structure is particularly sensitive to these shifts. Cellular arrangements that function effectively under high pressure can behave differently when that pressure is reduced. Membranes may become more flexible, fluids may redistribute, and the overall integrity of the body can appear altered. These changes occur without external injury, arising solely from the difference in environmental conditions. Understanding this process allows for a clearer interpretation of deep-sea organisms. It highlights the importance of context, showing that appearance cannot be separated from the conditions in which it is observed. A form seen at the surface carries with it the effects of its transition, and without considering that transition, conclusions about its natural state remain incomplete. In this way, the problem is not with the organism itself, but with the perspective from which it is viewed. The deep ocean shapes life in ways that are closely tied to its conditions, and when those conditions are removed, the resulting appearance reflects a different set of forces. Recognizing this distinction allows the original form to be understood more accurately, even when it cannot be directly observed. Long after it left the seafloor, the image continued to travel, moving through screens and conversations, taking on meanings that had little connection to its origin. In the digital spaces where it appeared, the blobfish became more than a specimen. It became a symbol, shaped by repetition, humor, and the tendency to simplify what is unfamiliar into something easily recognized. Memes formed around its image, using its altered appearance as a starting point for interpretation. Captions were added, expressions assigned, and meanings constructed that reflected human perspectives rather than biological reality. The fish was no longer seen as part of a distant ecosystem, but as a figure that could be understood through comparison to familiar emotions and forms. Each iteration reinforced this perception, building a shared understanding that spread across different communities. This process influenced how the blobfish was perceived on a global scale. For many, it became known primarily through these representations, its identity shaped by the context in which it was shared. The simplicity of the image allowed it to circulate widely. detached from the conditions that had originally defined it. Over time, the repetition of this portrayal created a lasting association, one that persisted even as more information became available. Within this shift, science communication faced a particular challenge. The original context of the blobfish, its environment, its adaptations, and the reasons behind its altered appearance required explanation that extended beyond a single image. Conveying this complexity within the fast-moving flow of digital media proved difficult. Detailed understanding often gave way to simplified narratives, where accuracy was secondary to immediacy. Efforts to provide clarity introduced additional layers to the conversation. Scientists and educators began to explain the role of pressure, the nature of deep-sea habitats, and the processes that led to the blobfish's surface appearance. These explanations offered a more complete perspective, yet they had to compete with the established image that had already taken hold. The contrast between the two representations highlighted the gap between scientific understanding and public perception. At the same time, the widespread recognition of the blobfish created unexpected opportunities. Its familiarity drew attention to the deep ocean, encouraging interest in environments that are rarely considered. Discussions that began with its appearance often expanded to include broader topics, such as deep-sea ecosystems, adaptation, and the challenges of exploration. In this way, the image served as an entry point, leading to a deeper engagement with scientific ideas. The cultural impact of the blobfish extended beyond its role as a subject of curiosity. It appeared in media, educational materials, and public discussions, becoming part of a shared reference point. Its image, once a simple record of a specimen, transformed into a widely recognized icon, carrying meanings that evolved over time. This transformation reflects the way information moves in the modern world. Images can travel quickly, shaping understanding through repetition and interpretation. The blobfish, through this process, became a case study in how perception can be influenced by context, and how that context can shift as information spreads. Despite these changes, the underlying reality remains unchanged. The organism continues to exist in its environment, its form and behavior defined by the same conditions that have shaped it over long periods. The image that circulates widely represents only one moment in its existence, a moment that has been interpreted in many ways. In this convergence of science and digital culture, the blobfish occupies a unique position. It stands at the intersection of observation and interpretation, its identity shaped both by its biology and by the ways in which it has been represented. Far from view, where observation remains limited, questions about survival unfold without clear answers. The blobfish exists within a region that is rarely monitored in detail, and much of what is known about its presence comes from scattered encounters rather than continuous study. This absence of consistent data makes it difficult to determine how stable its population may be, or how it responds to changes in its environment. Fishing activity reaches into these depths, not always with the intention of targeting species like the blobfish, but through methods that extend across the seafloor. Deep-sea trawling, in particular, moves through the same regions where these organisms live, collecting a wide range of species along its path. In this process, the blobfish can be caught unintentionally, appearing among other forms brought to the surface. The impact of such encounters is not always easy to measure. Individual specimens may be removed, yet without a clear understanding of population size or distribution, it remains uncertain how these losses affect the species as a whole. Some areas may support stable populations, while others could be more vulnerable, depending on local conditions and the frequency of disturbance. Limited data contributes to this uncertainty. Unlike species that inhabit more accessible environments, the blobfish cannot be observed regularly over time. Surveys provide only brief snapshots, and long-term monitoring is difficult to maintain. As a result, patterns of abundance, reproduction, and movement are not fully understood, leaving gaps in knowledge that make assessment challenging. Beyond direct capture, broader changes in deep-sea ecosystems introduce additional considerations. Human activity influences the ocean in ways that extend far beyond the immediate area of interaction. Changes in surface conditions, such as temperature and chemistry, can gradually affect deeper layers, altering the distribution of nutrients and the overall balance of the environment. These shifts occur slowly, yet their effects may accumulate over time. The seafloor itself, shaped by long periods of stability, can be sensitive to disturbance. Activities that alter its structure may have lasting consequences, influencing the habitats that support various species. Recovery in these regions does not follow the rapid cycles seen in more dynamic environments. Instead, it unfolds gradually, with changes persisting over extended periods before returning to their previous state. For the blobfish, which depends on the consistency of its surroundings, such disturbances may influence its ability to maintain stable conditions. The extent of this influence remains uncertain, as direct observations are limited. What can be inferred suggests that stability plays an important role in its continued existence, and any disruption to that stability may have effects that are not immediately visible. Efforts to understand and manage these impacts continue to develop, guided by the recognition that deep-sea ecosystems are interconnected with broader ocean processes. Conservation in this context involves not only protecting individual species, but also maintaining the conditions that support them. This requires an approach that considers both local interactions and wider environmental changes. The blobfish, within this framework, represents a species whose status is not fully defined, yet whose environment is increasingly influenced by human activity. Its presence in these depths reflects a balance that has persisted over long periods, shaped by forces that operate slowly and consistently. In the absence of complete information, the questions surrounding its conservation remain open, shaped by the same quiet uncertainties that define much of the deep ocean. Beyond the reach of routine observation, the ocean continues into regions that remain largely uncharted, extending far past the limits of what has been carefully mapped or directly studied. These depths cover vast portions of the planet, yet they are known only through fragments of data, gathered in isolated moments and assembled gradually over time. What lies there is not entirely hidden, but only partially revealed, its full extent still unfolding. It is often noted that more than 80% of the ocean has yet to be explored in detail. This figure reflects not only the physical scale of the ocean, but also the challenges involved in reaching its deeper layers. The conditions that define these regions, pressure, distance, and limited access, make systematic exploration difficult to sustain. Each expedition provides a small window, offering insight into a specific location while leaving countless others unobserved. Within these unexplored areas, new species continue to be identified. Advances in technology have allowed researchers to reach previously inaccessible depths, capturing images and collecting data that reveal organisms not seen before. Some are entirely unfamiliar, their forms unlike those documented in earlier studies, while others belong to groups that have been only partially understood. Each discovery adds to a growing record, expanding the understanding of life in these environments. The process of discovery is gradual, shaped by the pace at which exploration can occur. Unlike regions that can be surveyed continuously, the deep ocean is studied through intermittent efforts, each one contributing a small piece to a much larger picture. Over time, these pieces begin to form patterns, suggesting a level of diversity that extends far beyond current knowledge. This sense of ongoing discovery has led to the description of the deep sea as one of Earth's final frontiers. The term reflects not only the physical distance from familiar environments, but also the extent of what remains unknown. It is a place where the boundaries of understanding continue to expand, guided by each new observation and the questions that follow from it. The blobfish exists within this broader context, part of a world that is still being revealed. Its presence, once known only through indirect encounters, is now understood within a wider network of species that share similar conditions. Yet, even with this growing awareness, much about its environment and behavior remains uncertain, shaped by the same limitations that affect the study of the deep ocean as a whole. Exploration of these depths continues to evolve, supported by improvements in technology and methodology. Remote vehicles can travel further and remain longer, capturing more detailed observations. Sensors provide data on temperature, pressure, and chemical composition, offering a clearer picture of the conditions that define these environments. Each advancement extends the reach of observation, bringing more of the deep ocean into view. Despite this progress, the scale of what remains unknown is significant. The ocean's depth and extent ensure that many regions will remain beyond detailed study for the foreseeable future. This does not diminish their importance, but rather highlights the ongoing nature of exploration, where understanding grows gradually through continued effort. Within this vast and largely unexplored domain, life persists in forms that reflect the conditions of their surroundings. Each species represents a point of adaptation, shaped by forces that operate steadily over time. The deep ocean, in its quiet and expansive reach, remains a place where discovery continues, not through sudden revelation, but through the steady accumulation of knowledge that brings its hidden complexity into view. Consider a form that does not strive against its surroundings, but instead settles into them with quiet precision. The blobfish offers an example of this approach, not through dramatic features or visible strength, but through a subtle alignment with the conditions that define its existence. Its body, behavior, and overall presence reflect a process of adjustment that has unfolded gradually, shaped by forces that remain constant over long periods. Within its environment, the blobfish is not unusual. It is well matched to the demands placed upon it, existing in a state that requires little excess effort. Each aspect of its structure contributes to this balance, allowing it to maintain position, conserve energy, and persist where resources are limited. What may seem unfamiliar when viewed from a different context becomes, in its proper setting, an example of efficiency shaped by necessity. This perspective reveals something broader about adaptation itself. Evolution does not produce a single ideal form, but a wide range of solutions, each suited to specific conditions. In the deep ocean, where pressure is immense and energy is scarce, the solutions differ from those found in environments that are more variable or abundant. The blobfish embodies one of these solutions, its form reflecting the unique combination of factors that define its world. The process that leads to such forms is not directed toward appearance, but toward function. Over time, features that support survival are retained, while those that do not gradually disappear. The result is a structure that may not align with familiar expectations, yet operates effectively within its environment. This divergence highlights the diversity of pathways that evolution can take, each shaped by the specific challenges encountered. In this context, creativity emerges not as an intentional act, but as the outcome of countless small changes accumulating over generations. Each adjustment builds upon the last, refining the organism in response to its surroundings. The blobfish, through its composition and behavior, represents a point along this continuum where the accumulation of changes has produced a form that fits closely with its environment. Life in such settings demonstrates that thriving does not require abundance or visibility. It can occur in conditions that appear limiting, where stability and persistence replace rapid growth or expansion. The blobfish exists within this framework, its survival supported by a careful balance between its needs and what the environment provides. This balance extends beyond a single species. It reflects a broader principle seen throughout the deep ocean, where organisms adapt to conditions that remain steady yet demanding. Each species contributes to a system that operates without urgency, where interactions unfold slowly and where survival is achieved through consistency. The lessons drawn from this are not confined to the deep sea. They suggest that adaptation is a process shaped by context, where success depends on alignment with the surrounding conditions rather than on comparison to external standards. The blobfish, in its quiet way, illustrates how life can take forms that are perfectly suited to environments that differ greatly from those more commonly observed. Through this lens, what once seemed unusual becomes a reflection of a different kind of order. The features that define the blobfish are not arbitrary, but the result of a long and continuous interaction between organism and environment. Each aspect of its existence contributes to a form that persists, not by overcoming its surroundings, but by existing within them in a state of quiet equilibrium. In this way, the blobfish offers a perspective on adaptation that emphasizes harmony over resistance, revealing how life can take shape in ways that are both unexpected and precisely suited to the world it inhabits. Placed within its own environment, the blobfish does not stand out as unusual. It settles into the surrounding conditions with a kind of quiet precision, its form neither excessive nor lacking, but closely matched to what is required. Every aspect of its structure aligns with the demands of the depth it inhabits, forming a balance that allows it to persist without strain. This alignment reflects a long process of refinement. Over extended periods, small adjustments accumulate, each one shaping the organism in ways that improve its ability to function within its surroundings. The result is not a form that seeks to impress or dominate, but one that fits. It operates within a narrow range of conditions, maintaining stability through features that have been preserved because they work. Seen in this way, the blobfish becomes a success story of evolution, not through dramatic adaptation, but through consistency. Its body, behavior, and overall presence demonstrate how life can achieve stability by matching the environment in which it exists. There is no excess structure, no unnecessary complexity, only what is needed to maintain balance over time. The conditions that define its world, pressure, limited energy, and a steady pace of change, shape what is possible. Within these constraints, the blobfish represents a solution that allows survival without constant adjustment. It does not need to respond rapidly to shifting circumstances because those circumstances remain relatively constant. This stability allows its form to remain consistent, refined to suit a specific set of conditions. From a different perspective, this same form may appear unfamiliar. When viewed outside its environment, without the forces that support it, its structure seems altered, its features less defined. This contrast highlights the importance of context, showing that appearance cannot be separated from the conditions in which it is observed. What seems unusual in one setting may be entirely appropriate in another. The idea that something can appear strange yet function effectively is central to understanding adaptation. Evolution does not produce forms based on external expectations, but on the requirements of survival within a given environment. The blobfish illustrates this principle through its alignment with its surroundings, where each feature contributes to a stable and enduring existence. In this context, its design is not accidental. It reflects a series of adjustments that have been tested over long periods, each one contributing to a form that persists. The absence of features that are common in other environments is not a limitation, but a reflection of different priorities. Strength, speed, and visibility give way to balance, efficiency, and continuity. The success of the blobfish is measured not by how it compares to other species, but by how well it exists within its own environment. It maintains its position, obtains the resources it needs, and continues its life cycle within conditions that remain steady. This persistence, sustained over generations, reflects a form of success that is quiet but enduring. Within the broader context of life in the deep ocean, the blobfish is one of many organisms that demonstrate how adaptation can lead to forms that differ significantly from those found elsewhere. Each represents a response to specific conditions, contributing to a diverse range of solutions that allow life to continue in varied environments. Through this lens, the blobfish becomes less a curiosity and more an example of how evolution shapes organisms to fit their world. Its form, when understood within its proper context, reveals a balance that is both precise and effective, a result of long adaptation to conditions that remain constant across time. In the quiet distance beneath the surface, where observation fades into suggestion, the deep ocean remains a place shaped as much by what is unseen as by what has been revealed. The blobfish, carried into awareness through fragments and images, has come to represent more than a single species. It stands as a reminder of how much of this world exists beyond direct understanding, known only through brief encounters and careful interpretation. Its story traces a path between two perspectives. On one side, a surface image, altered by conditions far removed from its origin, became widely recognized and easily understood. On the other, a deeper reality, shaped by pressure, stillness, and time, remained largely hidden. As knowledge expands, these perspectives begin to align, revealing a more complete picture that connects appearance with environment. This shift in perception does not happen all at once. It unfolds gradually as new information is gathered and integrated into what is already known. The initial impression, formed quickly and shared widely, gives way to a more detailed understanding, one that requires attention and context. In this process, the blobfish changes not in form, but in meaning, becoming less a curiosity and more an example of how life adapts to specific conditions. The deep ocean continues to hold countless forms that have yet to be observed in detail. Each exploration adds to the record, yet also reveals how much remains beyond reach. The scale of this environment ensures that discovery will continue over long periods, with each new finding contributing to a broader understanding of the systems that operate there. Within this vast and largely unexplored domain, the principles that shape life remain consistent. Organisms adapt to their surroundings, developing forms that reflect the conditions they encounter. The blobfish, in its alignment with pressure and limited energy, illustrates how this process can lead to outcomes that differ significantly from those found in more familiar environments. As these insights accumulate, the way we interpret such organisms begins to change. What once seemed unusual becomes more understandable, not because the organism itself has altered, but because the context has been restored. The connection between form and environment becomes clearer, allowing appearance to be seen as part of a larger system rather than as an isolated feature. This understanding extends beyond a single species. It offers a perspective on the deep ocean as a whole, highlighting the importance of viewing it within its own terms. The conditions that define it, pressure, darkness, and stability, shape life in ways that are consistent within that environment, even if they appear unfamiliar from the surface. The blobfish, in this sense, becomes a point of connection between what is known and what remains to be discovered. Its presence in both scientific study and public awareness bridges these two realms, encouraging a closer look at the processes that shape life far below. And in that distant, unlit world, nearly a kilometer beneath the waves, it continues, as it always has, suspended just above the seafloor, moving with the slow rhythms of its surroundings.